Question. The eigenvalue of a Hermitian matrix are all. Option A real, option B imaginary, option C of modulus 1 and option D real and positive. So in this question they have asked what is the nature of the eigenvalue of Hermitian matrix. So it's a direct question. The answer is option A. The eigenvalue of Hermitian matrix is always a real one. And if you take the option B, it corresponds to the skew Hermitian matrix eigenvalue. And option C is of a unitary matrix or a orthogonal matrix. In a spherical polar coordinates r, theta, psi, the unit vector at 10, pi by 4, pi by 2 is option A k cap, option B 1 by root 2 j cap plus k cap, option C 1 divided by root 2 minus j cap plus k cap, option D 1 by root 2 j cap minus k cap. So in this question they have given the polar coordinates and they have asked us to find what is the unit vector at this particular point, that is 10, pi by 4, pi by 2. First, we have to find the formula for the unit vector for spherical polar coordinates, and then we have to find the value of unit vector and substitute it. What is the value at 10, pi by 4, pi by 2. So first we will find the unit vector. Unit vector is equal to dou r by dou theta divided by modulus of dou r by dou theta. So for a spherical polar coordinates, our position vector is equal to xi cap plus yj cap plus zk cap. Here x is equal to r sin theta cos psi and y is equal to r sin theta sin psi and z is equal to r cos theta. Now substitute these values here in the position vectors. Then we will be getting this expression. First we have to find what is the value of position vector with the partial derivative of theta. So first we will find that dou r by dou theta is equal to r cos theta plus cos psi I cap plus r cos theta sin psi j cap minus r sin theta k cap. Next we have to find what is the modulus of dou r by dou theta. So dou r by dou mod of dou r by dou theta square is equal to, we have to square this term. Squaring this term and simplifying it, we will be getting r square is equal to cos square theta plus sin square theta. So sin square theta plus cos square is equal to 1. So we will be ending up with is equal to r square. So mod of dou r by dou theta is equal to r. Now we have to substitute the value of dou r by dou theta and r in the unit vector and find the what is the value of unit vector. So the unit vector theta cap is equal to r cos theta cos psi I cap plus r cos theta sin psi j cap minus r sin theta k cap divided by r. So r can be cancelled off from all the terms. So we will be ending up the term without r. Now at theta is equal to pi by 4 and theta is equal to pi by 2 and r value is equal to 10, the unit vector will be, substitute the values of theta and psi. This term doesn't contain the r, so we can leave it. So by substituting it, we will be getting the unit vector theta cap is equal to 1 divided by root 2 j cap minus k cap. Now if you see the option, the answer is option D, 1 by root 2 j cap minus k cap. Question 5. The scale factor corresponding to the covariant metric tensor in spherical polar coordinates are option A 1, r square, r square sin square theta, option B 1, r square sin square theta, option C 1, 1, 1, option D 1, r sin theta. So in this question they have asked us to find what is the scalar factor that is corresponding to the covariant metric tensor in spherical polar coordinate system. So the scale factor for Cartesian, cylindrical and spherical coordinate system in 3 dimension is, for Cartesian coordinate it is 1, 1, 1, and for cylindrical it is 1, r, 1, and for spherical coordinate it is 1, r sin theta. Therefore, for this question, the answer is option D, that is 1, r, r sin theta. Question 26. Given v1 vector is equal to I cap minus j cap and v2 vector is equal to minus 2i plus 3j plus 2k cap. Which one of the following v3 vector makes v1, v2, v3 a complete set for a three-dimensional real linear vector space? Option A, v3 vector is equal to I cap plus j cap plus 4 cap. Option B, v3 vector is equal to 2 I cap minus j cap plus 2k cap. Option C, v3 vector is equal to I cap plus 2 j cap plus 6k cap. Option D, v3 vector is equal to 2 I cap plus j cap plus 4k cap. So in this question they have said the vectors v1, v2 and v3 forms a complete set of for a three-dimensional linear vector space, and they have asked us to find what is the value of this v3 vector. So the condition to form a three-dimensional linear vector space is the determinant is not equal to 0. So the given vector v1 is equal to I cap minus j cap and the vector v2 is equal to minus 2 I cap plus 3 j cap plus 2 k cap, and let us consider the vector v3 is equal to x I cap plus y j cap plus z k cap. Now we will form the determinant for the vectors, that will be 1 minus 1 0 and minus 2 3 2, and v3 is x y and z. Therefore by simplifying this we will be getting the determinant d is equal to minus 2x minus 2y plus z. Now we will take all the four options and take all the xy values and substitute in this determinant and check whether it is not equal to 0 or not. First we will take the option A. Here the xy value is 1, 1, 4. So the determinant, if you substitute the value in the D, we will be getting it is equal to 0. So this is not V3. So then we will take option B. Similar way we will take option B and option C and check. We will be getting the determinant is equal to 0. Now we will be checking for the option D, that is x, y, z is 2, 1 and 4. For this the determinant value is equal to minus 2. Only for the option D, that is V3 is equal to minus 2i plus j and plus 4k cap, the determinant is not equal to 0. Therefore, answer is option D. Question: d square f of x by dx square minus 2 df of x by dx plus f of x is equal to 0. And the boundary condition f of 0 is equal to 1, f of 1 is equal to 0. The value of f of 0.5 is dash. So in this question they have given a differential equation, that is second order equation, and also a boundary conditions are given, and they have asked us to find what is the value of f of 0.5. So first we will write the given second order linear differential equation. D square f of x by dx square minus 2 df of x by x plus f of x is equal to 0. This equation has an auxiliary equation of m square minus 2m plus 1 is equal to 0. Therefore we will be getting a root as m is equal to 1, 1. Both the roots are identical. Therefore, we can write the general solution for f of x as c1 plus c2x the whole e power x. In the question, they have given a two boundary condition. By using the first boundary condition, we can find what is the value of the constant. C1 plus C2 of 0 into e power 0 is equal to 1. Therefore, we will be getting C1 is equal to 1. Now by using the second boundary condition, we will find the value of C2. C1 plus C2 of 1 into e power 1 is equal to 0. So we will be getting C1 plus C2 into e is equal to 0. From the previous boundary condition, we have obtained the value of C1. Substitute the value of C1 here and we will be getting 1 plus C2 into e is equal to 0. So here C e cannot be equal to 0, e power 1. Therefore, 1 plus C2 must be equal to 0. Therefore, we will be getting C2 is equal to minus 1. Now we have found what is the value of C1 and C2. Now we need to find what is the value of f of 0.5. So we have found the solution f of x is equal to C1 plus C2 x into the whole power e power x. Now substitute the value of C1 here, C2, x value is 0.5 and here also 0.5. We will be getting 1 minus 1 into 0.5 e power 0.5. By simplifying it, we will be getting 0.82. Therefore, the value of f of 0.5 is 0.82. Question. The absolute value of the integral 5z cube plus 3z square divided by z square minus 4 into dz over the circle z minus 1.5 is equal to 1 in complex plane is. So in this question they have given an integral and they have asked us to evaluate the value of the integral over this particular circle they have given. So first we will write the given integral. I is equal to integral 5z cube plus 3z square divided by z square minus 4 into dz. So we will find the poles. So pole is equal to z square minus 4 is equal to 0. So by equating it to 0, we will be getting z is equal to plus or minus 2. So it has a 2 pole. One is plus 2 and another one is a minus 2. Now if you take the given circle, it has a center value of 1.5 and radius value of 1. Now if you see the given pole, plus 2 and minus 2 are the two poles, right? The pole plus 2 alone will be lying inside the circle and the pole minus 2 will be lies outside the circle. So it is enough to find the residue at z is equal to plus 2 alone. So first we will be finding the residue at z is equal to 2. Limit z goes to 2, 5z cube plus 3z square z minus 2 divided by z minus 2 z plus 2. Z minus 2 and minus 2 will get cancels off and then we'll be getting 5z cube plus 3z square divided by z plus 2. By applying the limit we will be ending up with residue as 52 divided by 4. Now integral I is equal to 2 pi into residue z is equal at z is equal to 2. That is residue is 52 divided by 4 into 2 pi I. By simplifying it, we will be getting 81.68 I. In the question, they have asked only the absolute value. So the absolute value is 81.68. Question. The number of independent components of a general electric field tensor is dash. In this question they have asked us to find how many number of independent components are there in a electric field tensor. So the electric field in tensor is Eij is equal to Exx, Exy, Exz, Exy, Eyx, Eyy, Eyx, Ezx, Ezy, Ezz. So if you take the electric field has a three independent components, that is this one diagonal components Eyy and Ezz. So total independent component in electric field is 3. In the similar way, the magnetic field tensor has a three independent magnetic field components Buxx, Byy and Bzz. So the total number of independent components in the electromagnetic field tensor is 3 plus 3 is equal to 6.
In the description box, you can find solution for GATE Physics 2020 and 2019 question papers. Please share and subscribe the channel. If you have any queries, write in the comment section.